Okay, so let's see for number 20. Elena, what do you have for number 20?
For 20, I got the square root of 146.
Square root of 146. Okay, so let's take a look at this guy. Oops, there we go. All right, so you are taking the difference between the x value, so that would be 6 minus -5. So actually that would end up becoming 11, and you would have 11 squared plus, let's see, 4 minus -1 would end up becoming 5. So we would have 5 squared. And that, of course, will end up giving us 11 squared would be 121, 5 squared would be 25. So yeah, that is adding up to square root of 146. And we cannot simplify this further, because if we divide 146 by 2, you are getting 73, right? So we're not able to bring anything outside, which will simplify as a radical. So yeah, very good. Just leave it at square root of 146. Okay, very nice. Angelo, what do you have for 21?
For 21, we got square root of 40.
Okay, square root of 40. So let's take a look at this guy. That would be 3 minus 9, which would end up giving us -6. We square that. 8 minus 10 would be -2 squared. So that would end up giving us positive 36 and positive 4. Square root of 40. But you know, with square root of 40, you can actually simplify that, because, you know, of course, we can write 40 as 4 times 10, right? So when you take a square root of 4 can come outside as 2, and you would be left with just 10 inside of your radical. So this guy you can simplify. So your simplified answer should be 2 times square root of 10. Okay, alrighty, very good. I'm actually gonna get rid of this. Alrighty, so let's see, that would be number 22. And Brandy, what did you have for 22?
I got the square root of 26.
Square root of 26. All right, let's take a look. So we would be doing 10 minus 9, which would just give us 1. So that's squared. 1 minus -4 would actually add up to 5. So that would be 5 squared. And let's see, that would just be 1 plus 25, which comes out to be square root of 26. And again, when we take 26 divided by 2, you get 13. So 13 times 2, and of course, none of those are going to be perfect squares. So for this guy, we can leave it as square root of 26. All righty, very good. Let's see for number 23. Maya, what did you have for 23?
The square root of 13.
Square root of 13. Okay, so that one obviously wouldn't be simplified. So let's take a look here. We have -8 minus -6. So that would actually end up becoming just -2 squared. 10 minus 7 would be 3 squared. So that will give us obviously 4 plus 9, which adds up to giving you 13. So yeah, square root of 13. All righty, very good. Mikhail, do you have 24?
I noticed that I was accidentally working from the very beginning of page 2 because I forgot that we had finished that yesterday, so I actually just now got to that one.
Okay. All right. Well, you take your time, and whenever you're ready, let me know.
All right, sorry about that.
Okay. So those of you who are at 25, 26, can you kind of tell me what are you thinking about this problem here for 25? They're saying name a point that is 2 square root of 2 away from -1, 5? How would you kind of come up with, because you know the square root of 2 is your distance, right? So they're telling you find a point that would be square root of 2 distance away from this -1, 5.
The way I thought about it was you have to get 2 points that would, whenever you subtract them, it would make each one turn into a 1. So it'd be 1 plus 1, and then you'd get the square root of 2.
Okay, okay. So what numbers were you kind of playing around with?
For the first one, my x was 0. And then for the second one, you could either do 6 or 4.
6 or 4, okay. Because if you did 0 minus 1, which actually would be 0 minus -1, so that would still add up to 1. You would get 1 squared, which would be 1. If you did 6 minus 5, that would still be 1, so that would be 1 squared. Or if you did 4 minus 5, that would still be -1. -1 squared would be 1. So yeah, 1 plus 1 would get you square root of 2. Okay, so that works out very good. Did anybody have a different point or a different strategy than what Katie is talking about? So if you think on the number line, you know, you've got -1, and what's that other point? +5. So if you're going 1 unit to the right to get 0, you know, technically you can also go 1 unit to the left and you can still have -2. So technically you can actually also have ordered pairs with -2 in there. And, you know, obviously you would still use 6 and 4 because they would be 1 above or 1 below. Because, you know, again, think about this. If you do -2 minus -1, you would still end up getting, you know, -1 as your answer. So when you square -1, that would still become +1. So you can use 0 for your x value, or you can also use -2. Did anybody have those points? -2, 6 or -2, 4? Okay. All right, that was really good. The other technique that I kind of talk to students about is you can think of, you know, this point -1, 5 being as the center of your circle, and then basically you have a radius of square root of 2. So if you actually draw that as a circle, and you know, of course you would need to have a grid, not a freehand, you will actually be able to see that the 4 points that we have listed here are going to be the 4 points where your graph or your circle will cross through those 4 points. So you can also think of this as the idea of using a circle with the center at -1, 5 and a radius of square root of 2. Okay, very nice. Mikhail, do you have 24?
Yeah.
What did you get for your distance for 24?
So for the distance for 24, I got the square root of 69.
Square root of 69?
And to get that, I did -5 minus 8 squared minus 6 plus 4 squared to get -13 squared minus 10 squared for.
Oh, you would be
169.
adding, not subtracting.
Wait, dang it. Okay, whoops. Sorry.
That's okay. Because yeah, when you're doing -5 minus 8, you would get -13, and then we square that. Then we would be doing 6 minus -4, so that would actually add to give you 10 squared. So when you change that to a plus, what will you end up getting?
You get the square root of 269. I'm trying to see what that simplifies into, if it can, like if the fraction, or not the fraction, if the square root can simplify to something easier to read.
Yeah, because you're getting with negative 13 squared, we get 169. 10 squared, of course, is 200, and then that adds up to 69. Will that simplify? It's definitely not a perfect square by itself. So, Mikhail, were you able to simplify it?
Not yet, no. It doesn't look like it is able to simplify.
Okay. Yeah, because I've tried quite a few different combinations myself, and it doesn't seem to be. Alrighty, yeah, so just leave it at square root of 269. Alrighty, very good. Now, can you guys tell me, what are you kind of thinking for number 26 over here? Name a point that is between positive 50 and positive 60 units away from 7 and negative 2, and state the distance between the 2 points. So they're again actually giving you the distance, right? They're saying it is between 50 and 60 units away from 7 and negative 2, and they want to state, what the distance between the 2 points will be. So basically the distance can be 50, 51, 52, 53, 54, up to 60. So kind of similar to what you did in 25, but now they're giving you a range of your distance to be between 50 to 60 units. So how far will we need to go with our ordered pairs? Okay, Brandy, you are saying with the points 43 and 34 work. So are you using 43 for the X value and 34 for the Y value?
Yes.
So let's do that here. Okay, so we've got the ordered pair 43 and 34. And of course, our original ordered pair is 7, -2. So let's see what happens when we try to find the distance here. So that would be 43 minus 7. So that would be what, 36 squared, plus if we did 34 minus -2, we're technically adding it. So this is coming out to be 36 squared plus 36 squared. So let's see, 1,296 plus 1,296. Okay, so square root of 25,982. Oops, did something wrong. Okay. So you are not getting a clean answer. I mean, technically, as you can see, you're definitely between 50 and 60 units. And I guess they're not specifically telling us to be, you know, a whole number. So I guess technically your answer can be Brandy, because you are getting a distance of approximately 50.911. Okay. But let's say if we wanted to just stick with, whole numbers. So we will say, okay, this guy is good. But if we wanted to stick with whole numbers, think about something like, and the example I have here is 60 and -2 with our original ordered pair of 7 and -2. So when you calculate the distance here, 60 minus 7 will of course give us 53 squared. And then when we add -2 with subtract -2 and -2, you will actually end up getting 0. So you will see how you are basically ending up with 53 squared and then a square root on that. And, of course, your distance will come out to be 53. And this guy here will actually have, endless different combinations, because they're telling you the distance can be anything between 50 and 60. So kind of work backwards and say, okay, if I wanted the distance to be 60, then what numbers can I play around with and see what that leads you. So just pick, whatever distance you want to kind of play around with and see what ordered pair you come up with. There we go. So when you have an ordered pair that you think will work, let me know. Another ordered pair here. So now you're using 62 and -2. Okay, so when we do our distance calculation here, we will again do 62 minus 7. So that will be what, 55? And then you're still getting 0 for your 2. So were you getting a distance of 55 then, Brandy?
Yes.
Okay. And you know, don't just keep using -2 for your y value. You know, try and think a little bit outside of the box. So Maya, you've got 67 and -2, so this will give you a distance of 66. So instead of just using -2 for the y value, what else can we do? Anyone else have an ordered pair that you think would work? Okay, let me show you another technique, then you guys can work. So like I said, you know, let's say we want to start backwards and we want to have a distance of 59 units. So to have a distance of 59 units, we want to end up in a situation, you know, where we can have from our distance formula 59 squared inside the square root. So we know they can cancel each other out and you get a distance of 59. So that means, you know, our total on the inside should somehow work out to be 59. So think about this, you know, what if we made our y value 0 in the ordered pair that we're trying to come up with? So we know 0 minus -2 will of course add up to +2, and then when you take a square on it, you would get 4. So if one of our total values is going to come out to be 4, well, 4 plus what will give us a total of 59. So, you know, you can just do 59 minus 4, and that would tell you, well, we need to get 55. So what number can you have in here which gets subtracted from 7, you know, which would end up giving you a total of 55? So, you know, just take 7 plus 55, and of course that would tell you, you know, this number here should be a 62. So now when you put this into your formula, you would do 62 minus 7 for that x values. You know, we would do 0 minus -2 for our y values. And then when we square this, 62 minus 7 would be, no, sorry. I actually need to not have this come up as 55 because my total has to be 55 plus 4, which would give us 59. Hold on a second. I was not thinking about the squares when I was working through this. So if we did 62 minus 7, that would give us 55, but then I still need to square that. Okay, so that will not work because I need a number which will be a perfect square, which will be 55. So what can I go down to? Well, I can actually, let's see, if I can make this 49, Because 49 is a perfect square. 49 plus 4 will give us 53. So I can actually change this to a distance of 53 units. And to get a total of 7. You know what? I can actually use the origin if this math will work out for us, because I could do 0 minus 7, which would give me negative 7 squared. Of course, on this side where I'm doing 0 minus negative 2, that would give me positive 2 squared. We know 7 squared is going to be 49. 2 squared is going to be 4. So 49 plus 4 will give us 53. Okay, no, I am completely butchering this problem because I need 53 squared, and this is just coming out to be 53. I don't know, when I did this problem yesterday, it worked out. So let me see what I'm doing wrong today. Okay, so if I want distance of 53 units, this has to come out to be 53 squared. Okay. So let's see what we need to fix here. Oh, I know what I did. 1 second. Because I think the other way was actually by leaving the 7 as it is, because when you did 7 minus 7, you know, that would of course end up giving us 0 squared, and then you could modify the y value to get you your total that you wanted. So yeah, it wasn't the y value we were keeping the same, it was the x value, and then that would work out for you. So now you can actually work backwards with whatever distance you want, and then that will help you decide, you know, what kind of y value you want to put in here. So what do you think we should put in there if we wanted to get a distance of 53, since that's what I have here right now? What number could we use for our y value?
$51.
Yeah, you can use 51 because you will end up doing 51 minus negative 2, you know, which would add up to 53. So then, of course, you would end up getting 53 squared from the y values, 0 from your x values, and you would still end up getting that same distance of 53. Because, you know, that would, of course, be the easiest way to come up with your ordered pairs. So just keeping, you know, the y value at negative 2 is, of course, one way, but you can keep the 7 also. Now, if you don't care about getting whole number answers and you want to just, you know, plug different numbers, you can kind of do what Brandy did, but, you know, obviously then you're not going to get whole number distances. You are going to get these decimal answers in there. And like I said, you know, they didn't specifically tell us what kind of answers they wanted, so it does kind of leave you open with those options. So these were some of the answers we came up with. Let's see, you also had 60 to -2. This is, of course, where we were keeping all the y values at -2. And then let's see, you can do 7 and 51. And then, of course, Brandy's original, which was 43 and 34. So you will have a whole bunch of different ordered pairs that you can come up with, you know, to satisfy this. Alrighty, so this was just part of the critical thinking questions here with this distance formula. Now your next handout is actually kind of interesting because this is where they're asking us to do some graphing, and what I actually have for you guys is a couple different examples. Not what I meant to do. There we go. So this is, again, just to kind of help us out with the graphing. And I thought this was a really neat assignment. This one is talking about, if it will let me open up my little chat window, is again to look at, you know, our slope of the line and to try and see, you know, if we can land the plane. But basically the idea is, you know, you have to align the plane with the landing strip. So let me just show you a preview over here. So this starting one is basically just talking about, you know, positioning the plane and trying to see if you can line it up with your landing strip to try and see if, you know, it will be right in the center of your landing strip. And you can see I'm a little bit off. So I obviously did not land the plane safely. But then as you move forward, you will see they start putting this on a grid. They're giving you an equation and you're still doing the same thing. You are still looking at landing your plane, but now that you have that equation, well, using that equation, does it make it easier? And you can see how those lights turned green and our plane is right in the center. So we obviously landed safely. So this is all about, you know, where your y-intercept is going to be, where the slope of your line is going to be, and how you can do that. So it's not a very long activity. It just kind of takes you through different scenarios. So again, let me see what you guys are able to come up with. So I just sent the link through the chat, so you should be able to get into the assignment. Send the So yeah, it looks like some of you have already moved on to the second one, and Mikhail, looks like you're actually ahead of the others. That's good. Okay, some of you actually did well on that first screen. Looks like Anna and Katie, you guys were able to land that plane nicely. That's good. Most of you are doing great on number 2, so that's good. Very nice. And then as you move forward, they're actually asking you to find what the equation of the line should be so that, you know, your plane aligns with the slope. And some of you seem to be doing good on that one. Mikhail, looks like you did well on that. That's very good. Alrighty. All right, great job. All of you did well on number 2. Number 3 really is not a question. I think they're just instructions, and then you just move on to number 4. And let's see, Braden, Mikhail, Elena, Katie, Brandy, Maya, and Angelo, you guys are doing good on number 4. Anna, it looks like you might have skipped over number 4. At least that's what it's showing at my end. So, you know, the idea behind this activity is you have to see, should my line have a positive slope? You know, should my line have a negative slope? So based on that, you kind of have to align, you know, if you look at that center line in the strip of your landing strip, that kind of helps you as a guide with what the slope of your line should be. And then, you know, if you kind of follow that line along, it will let you know what your y-intercept should be. So you're basically coming up with what the slope and the y-intercept should be, so that, you know, of course, your plane should land safely. So those are kind of the things you are looking for in those little graphs that are given to you. So it looks like Mikhail and Angelo, you guys did good on number 5. Braden, you as well, very good. Alrighty, let's see, looks like most of you are actually on number 5. Okay, Elena, very good on number 5. Good job. And looks like Katie, you also got number 5 correct already. Very nice. Anna, Jack, did you guys need any help, or you think you're doing okay with those?
I think I'm getting close.
Okay, very good. Yeah, so Anna, with your equation, you can see that your line is a little bit too steep compared to the runway. So you will need to probably try and use a fraction for your slope and see if that will help you get in line with the landing strip. Alrighty, very good. For number 6 screen, also Braden, Mikhail, Elena, Katie, and Angelo, those look good. Alrighty, very nice. It looks like all of you got number 4 correct. Okay, very nice. Alrighty, very good. Okay, so Maya, your number 5 is not landing safely. Alrighty. Maya, are you talking about number 5? Yeah, okay, let's take a look here. So, yeah, that negative slope looks good, but your numbers, I think, might need to be changed a little. Let's see. when we look at the line itself, let's see if we can find some happy points in there. Trying to see if any of the points are numbers that we can actually use. So I'm looking at, let's see, the ordered pair +9 and +9. Can you find that on your screen? And then the other ordered pair that I'm looking at would be +12 and +7. So if you use those 2 points as your guiding points, try and see what kind of slope do you have between those 2 points if you try to go from one point to the other. So those 2 points were, what did I have? 9, 9, and then the other one was 12, 7. So how would that change your slope from, what you have in here? And of course, those of you who are working on number 5, you can use those same points to try and see what the slope of your line should be. Okay, I am liking, for number 7, Katie and Mikhail, the challenges you guys came up with. That's nice. Alrighty, very good, Maya. Yeah, number 5 looks good. Alrighty. And then let's see for number 6. I think I'd already seen some of these answers. Yeah, so again, the reasoning you guys have for number 6 and the answer you chose looks really good. And then looks like most of you are on 7. A couple of you are finishing number 5. Okay, Brandy, looking at your number 5, I would definitely recommend to change your y-intercept because looks like you are a bit too high, to be in line with the landing strip. So I would say start by changing your y-intercept, but we might need to change the slope also, but start with the y-intercept and see what happens. So Braden, your challenge for number 7 looks good. You can actually reduce your fraction for the slope because you know those two numbers can be reduced. But otherwise, that looks good. Let's see here. I think Elena, I'm looking at yours. It's interesting that you use a different form of the equation, but yeah, you can see that one also works out. So that's good. Katie and Mikhail had already looked at yours and those look good. Randy, you are almost there. So I would say just check your answer and you will have just minor adjustments to do in there. All right, guys, so what I would like you to do is just finish up these last couple problems that you are working on. I will come back and check on that. So if you have just a little bit of time to finish this assignment, go ahead and do that. And then I would actually like for us to do a little bit of practicing with graphing next time. I noticed in some of your exams, I haven't had a chance to go through your exam from today, but you know, the graphing was still a little bit of a problem that you guys were struggling with. You know, sometimes your graph was just a little bit off and you would end up missing that on your exam. So I would like to practice graphing a little bit next time. So that's what we'll do. And I think we've got a couple more handouts from this, you know, section, and then we will be ready to move on to our next section. So I will see you guys on Wednesday morning with our 9:15 class. So have a wonderful day, guys. Be careful, and I will see you on Wednesday. Bye. Take care.
All right, see you Wednesday.
Yeah, bye-bye. Bye, guys.